at Redox Reactions. Let's get started. Our main focus today is going to be on oxidation and reduction. Okay, with oxidation, we're going to pay more emphasis on how to determine the oxidation numbers of different elements, okay, in a compound or different molecules in that specific compound. Also, we're going to be looking at the important terminologies that embodies the whole chapter, okay, which is we have to know what an anode is, what a cathode is, a reducing agent, as well as the oxidizing agent, okay. We're also going to be looking at electrolysis of salt solution. That is, we're talking about a copper chloride or the sodium chloride solution. Lastly, we're going to be focusing on electroplating. Okay, what is the importance of electroplating? Why are we even electroplating in the first place? What is it that is done, okay, when we are electroplating? But now, so that we are able to meet our objective for today, let's look at our lesson objective for this specific lesson. By the end of today's lesson, I want you and I to be comfortable in defining what oxidation as well as reduction is. Also, by being able to identify oxidation and reduction reactions. Okay. Number two, to be able to determine the oxidation numbers of different molecules in a compound or a chemical equation. And lastly, to be able to determine and identify the reducing agent as well as the oxidizing agent in a chemical equation. That means that we have to know how is the reducing agent different from the oxidizing agent. All right, so let's look first at the prior knowledge. What is it that we know about this specific chapter that we should remind ourselves of? Remember that we had said that pure substances can be in a form of an element or can be in a form of what? Of a compound. Where we even went further to explain and define what an element is. We said an element is a substance that cannot be broken down into simpler substances by any chemical means. However, when we look at the compound, we say it is a substance that consists of two or more of the elements that are chemically bonded to each other at a specific ratio. Okay, so we're going to be using more of the terms element, compound, pure substance, and all of that. Now, when we take a substance and it is decomposed, okay, or it is ionized just in water, it forms ions, okay? Now, ions can be in two forms. We can have a cation or we can have an anion. Remember, we spoke about how the cations form. Remember, when metals lose electrons, okay, they form the cation. Now, your cation are the positively charged ions, okay? And then we've got your anions, which are your negatively charged ions, okay? Those come from the nonmetals, which gain electrons, all right? So, we've got the two. The first one is your cation, positively charged ion, and then you've got your anion, which are negatively charged ions. Okay, with our cations, how they are formed is when the metals lose the what? The loose electrons, the loose valence electrons. And then how we form the anions is when the nonmetals gain electrons. Okay, so we went further to define what is a cation. It is a positively charged ion. What is an anion? It is a negatively charged ion. Okay, but we just based on then now the periodic table. Where exactly are our metals? Where exactly are our non-metals? And where exactly are our semi-metals? Okay, now let's look at then now how these then tend to have a certain charge. Remember, their ions have a specific charge, whether be it's a positive charge or whether be it's a negative charge. Okay, how can we then assign these charges on these elements or rather molecules of the periodic table? All right, so we say the charge of simple ions can generally be deduced from the group number, okay, in the periodic table. How? You ask yourself, how can then we assign these simple charges, okay, based on the group number of that specific element? So we've got group 1 and then group 2, group 13, group 14, 15, 16, 17, as well as 18. All right, the general charge of simple ions will be for group 1. Those elements will carry a +1 charge. That means it is a cation. And then for group 2, they carry a +2 charge. That is still a cation because it is positively charged and it is a +2. All right, and then for the group 13, it is a +3. All right, all of those are our metals because they are found on our far left hand side of the periodic table. All right, and then we've got group 14, which could be a positive or negative depending on the other element that it is reacting with at that particular time. Okay, could be positive or -4, meaning that it could be a cation or an anion. All right, and then we've got group 15. All right, on the further right hand side of the periodic table. Okay, now we're stepping into the non-metals. Okay, these are the ones that gain more of the electrons. All right, so their electrons are firmly bound and then they don't easily lose them, so they'd rather gain more of the electrons. All right, so that is why they are negatively charged. There is a negative charge that is there. So you to be speaking about your group 15, which have a general charge of -3. Okay, and then group 16 -2, group 17 -1, and then group 18 is 0. All right, so this is just a charge of simple ions based on the how they are assigned or how these elements are placed in the periodic table. All right, so what is it that we should remind ourselves of regarding the metals, the semi-metals, as well as the non-metals? What we need to know is that metals are good conductors of heat and electricity. They have between 1 as well as 3 electrons on the outer level. We call them, these are our valence electrons. They are loosely bound, meaning that we can easily lose them. All right, they are unlike our non-metal, which are poor conductors. Okay, they contain about 4 to 7 valence electrons. They are firmly bound. We don't easily lose them. They rather gain the electrons. All right, so and then we have our semi-metals, which are found in the middle. They sometimes behave like a non-metal, sometimes behave like a metal. Okay, so they are just in the middle, just as they are positioned. All right, so as you see, we have spoken also about the periodic table, which is going to be our best friend in this chapter. All right, so we've got our metals on the left hand side of the periodic table. Non-metals are based on the right hand side of the periodic table, as well as also we've got the semi-metals right in the middle, behaving sometimes like metals and sometimes like non-metals. Okay, so the periodic table just gives us a stretch out on how these elements are then placed. Remember, we had spoken about that they have a simple charge, okay, charge on how they are placed in the periodic table. So this is our group 1 that we're speaking about. Remember, we said group 1, group 2, group 13, 14, 15, 16, 17, and 18. Right. So now that we are looking at the periodic table, where exactly is that? So our groups, they go in columns, meaning they go from the top downwards, All right. So this is our group 1. What have we said? We said these ones are usually our +1. Or rather, they have a charge of +1. We have a plus what? A +2. Okay, then we have a what? A +3. And then we said for group 14, it could be a positive or a negative depending on the other element that it is reacting with. So it could be a positive or a negative what form. And then group 15, it is a -3, a -2, a -1, and then a 0. Okay, this helps us in understanding how the oxidation numbers are assigned to different elements in a compound. All right, so now before we even get any further, now let's look at the oxidation, the rules of the oxidation, or rather for assigning the oxidation numbers. All right, but before we even assign these oxidation numbers, what does oxidation mean? Oxidation is the loss of electrons. So when you see the word oxidation, it means the loss of what? Of electrons. All right, so with the oxidation number, what does it show? What does this oxidation number indicate? Oxidation number shows us the number of electrons that an atom either gains or loses. Okay, but how? Let's dive into the rules on how to assign these oxidation numbers. Rule number 1. It says a molecule consisting of only one element, okay, has an oxidation number of 0. That is a very important rule. Okay, a molecule consisting of only one element has an oxidation number of 0, since now it is neutral in all. Let's give an example so that we don't forget this rule. Okay, for example, if we have two, okay, atoms of what? Of hydrogen in this case, that means that it will be 0. Okay, and then also we've got Br2 is going to be also what? 0, because it is a molecule that is consisting of only one element. Okay, so there's just two atoms of the same element. Therefore, the oxidation number is going to be 0. Okay, now moving right along on rule number 2. Monoatomic. Remember the word mono? Mono means one. Monoatomic ions. These are ions with only one element or type of atoms. They have the oxidation number that is equals to the charge. And it is equals to the charge because they're what? They are ions. Remember, ions can be positive or negative ions. And for the positive ions, we call them cations, right? And for the N ions, we call them, those are negatively charged ions, we call them N ions. All right, so that means that for the monoatomic ion, they have an oxidation number that is equals to the charge. Let's give an example. We've got Cl minus, okay? Because now it has a charge of minus, that means that the oxidation number for this specific atom is going to be what? -1. Why is it -1? Because there is just a 1 negative right at the top. It has a charge of negative. If it was a -2 or 2 minus, it would have had an oxidation of what? Of -2. Okay, another example will be that of magnesium. It is a cation in this case because it is positively charged, because it is a metal. So magnesium, it has having Mg2 plus. What does that mean? What will be the oxidation number for this specific monoatomic ion? It will be +2, because we are saying the monoatomic ion have an oxidation that is equals to that of its charge. All right, and then rule number 3: in a molecule or a compound, the sum of the oxidation numbers for each element in a molecule or compound will be equals to 0. So that means if we're having a compound or a molecule, it is deemed to be neutral. It is going to be equals to 0. Let's give an example. For example, there is no charge in H2O. All right, so it is a compound, and therefore it's going to be having an oxidation number of 0. Okay, and then in a molecule, that is our rule number 4, in a molecule, the element that has the most electronegative is assigned the negative oxidation number. Okay, for example, we're in carbon dioxide, carbon will be +4, whereas oxygen is going to be -2. All right, so that means that our oxygen is just the most electronegative one. All right, number 5, in a polyatomic ion. Poly means many. Okay, now in a polyatomic ion, and because now we're talking about an ion again, okay, the oxidation number is equals to the charge, just like we'd spoken in rule number 2, okay. In a monoatomic ion, we said that it will have an oxidation that is equals to its charge, okay. So now let's give an example for the polyatomic ion. All right, our polyatomic ion will be SO42 minus. Okay, so we're saying it will be, the oxidation number will be equals to its charge. So because there is a 2 minus, it's going to be equated, or rather have an oxidation number of -2. Okay, moving right along, rule number 6, an oxygen atom usually has an oxidation number of what? Of -2. Okay, and this is just visible even when we are assigning the charges based on the element allocation in the periodic table. It will be -2. But there is an exception, of course. One exception is in peroxide, whereby there is, for example, hydrogen peroxide, where oxygen has an oxidation number of what? Of -1. Okay, so that is the only case where then the oxygen atom will not have an oxidation number of -2, but rather have an oxidation number of -1 when it is in a hydrogen peroxide. Rule number 7, the oxidation number of hydrogen is often +1. Okay, also we can confirm this due to how or where it is placed in the periodic table. It is on group number 1, so it has a +1 oxidation number. There is an exception. That exception is in metal hydrides, when the oxidation number is -1. Remember what we said, that it depends on what that specific element is reacting to, okay, or rather which other element it is reacting to. All right, so for example, in this case, where we have a lithium hydride, where it is specifically having an oxidation of -1. All right, that is your hydrogen having an oxidation of -1 instead of +1. Rule number 8, the oxidation number of halogen, okay, is -1. Yes, the way it is placed, it is really having an oxidation of -1. Rule number 9, the elements in group 1 of the periodic table always have the oxidation number of +1. Remember, the exception is that of hydrogen when it is a hydrogen peroxide, for example. Okay, it is reacting to form a hydrogen peroxide. The last rule, because there are 10 rules, elements in group 2 of the periodic table have an oxidation number of +2, which is very good because now it is a metal. Those are metals rather, and then they easily lose electrons, and then they form the cations of +2. Okay, now these are all the rules that we have to apply or to think of when we are assigning the oxidation numbers, which indicates the loss of electrons, or rather the gain of electrons. Either or, there is the transfer of what? Of electrons. All right. Now, we're speaking about the redox because as it is broken down, these are two reactions that happen simultaneously. All right. And what does it mean? It means that we've got, if we split red and ox, okay, this red stands for the reduction, and then this ox stands for the oxidation. These are two reactions that happen simultaneously, and they involve the electron transfer. All right, so if I am losing electrons, these electrons are not going to be dropped down, or they're not going to fly out of the window, but they're going to be transferred to another object. Okay, so as the object A is losing the electron, it is transferred to another one. So as the other one loses, the other one does what? It gains. So that is why we call them the redox, because the other reaction cannot happen without the other. All right, they happen simultaneously. Also, we need to take note of the fact that redox reaction always involve an oxidation number. So the oxidation number is very important in alerting us, okay, about how many electrons have been transferred from one object to another. Not forgetting that the reduction and oxidation half reaction, they have to occur simultaneously. All right, they have to occur simultaneously. But now let's take it just one step at a time. Let's understand one concept at a time. All right, let's just fully dive into oxidation. What happens when oxidation reaction takes place? Okay, so this is an acronym or an abbreviation of how, okay, we can just remember the loss of electrons, that is oxidation. Every time when you hear the word or the term oxidation, always remember that this is the loss of electrons. Okay, and that specific substance that is undergoing oxidation is a reducing agent. Okay, also, then how can we tell it when we're giving a chemical equation? How can we tell that this substance have been oxidized, have undergone oxidation? We look at the oxidation number, okay, to tell us if it has increased or decreased. Okay, what is it that we should know when we're looking at oxidation? Is that the oxidation number will do what? Will increase. Okay, so when we're looking at oxidation, there will be an increase of the what? The oxidation number. All right, let's take a look at this example that there is here. We said there is a what? Lithium. So lithium, before, it had an oxidation of what? Of 0. Okay, because it is just lithium. It is neutral. There is no ion. It is not an ion or a cation. But however, this lithium then lost an electron, 1 electron. Okay, so then lithium over here is a positive 1. And why am I saying lithium here has an oxidation number of positive 1? Why? Because of the charge. This is a monoatomic ion, okay? Because there's just one positive right at the top, and it's a cation, so it's just going to be a positive 1. What does it mean? It has lost 1 electron. So lithium was okay here. It was a 0. But now lithium after it is what? It is a positive 1. So can you see now there is an increase in the oxidation number. Okay. Then we had mentioned that a substance that undergoes oxidation, okay, is a reducing agent. Okay, what is a reducing agent? You ask yourself. It is a substance that undergoes oxidation. Okay, and then we look at the next one. This is an abbreviation, GRAW. Gaining of electrons is reduction. Okay, what is reduction? Is the gain of electrons. Okay, when we are gaining electrons, what is it that happens? Okay, there is a decrease in the what? In the oxidation number. Let's take a look at it in a chemical equation. Okay, so chlorine over here, before it was a what? It was a 0. All right, and then over here it is -1. So from a 0 to a -1, there's a drop. I like putting it in a Cartesian plane so that it is very clear. So from a 0, which is in the center where the lines are intersecting, and then to a -1. So this is a drop in the oxidation number. Okay, so oxidation, there is an increase in the oxidation number, and then reduction, there is a drop in the oxidation number. Also, what is most important that we pay attention to is that the substance that is undergoing reduction, okay, is an oxidizing agent. All right, what is an oxidizing agent? It is a substance that undergoes what? Reduction. Okay. And then anode is an electrode. Now we're talking about the 2 electrodes that are very important for us to take note of. Okay, there's an anode and then there's a cathode. Anode, we abbreviated with saying an ox, so that all the time we remember what an anode is and then what happens in an anode. All right. Now, an anode is an electrode where oxidation takes place. And how are we supposed to remember all of that? We say NOx. This N stands for anode. It is where oxidation happens. Okay. And then we've got the red cat. Okay. Now, red cat, this red stands for reduction. It happens where? In the cathode. Okay. So, anode as well as the cathode, these are the two electrodes where oxidation happens, again where the reduction happens. In the anode, it is the electrode where oxidation always takes place, and on the cathode, it is an electrode where reduction takes place. Another important thing to remember is that when there is a loss of electron, okay, there is an oxidation that is happening, that reaction. So there's going to be an increase in the oxidation number. However, if now there is a reduction taking place, there's going to be a decrease in the oxidation number. Okay. Now, the first one, now we need to apply then the rules of oxidation, of assigning the oxidation numbers. Okay, remember what I said? I said in this chapter, the periodic table is going to be your best friend. Okay, know how to use it, know how to use it all the time, and implement it together with all the rules that we've spoken about. Don't worry, let's go through it together. This learning activity just says, determine the oxidation number of the elements indicated in each chemical formula. So for 1.1, it says we want to determine the CR in CrO42 minus. Okay, so the ones that we don't know, the oxidation number we're trying to determine in this problem is that of Cr, but in a polyatomic ion, which is CrO42 minus. What do we do? Because with the polyatomic ion, we said it is equals to, or rather the oxidation number of that polyatomic ion, okay, is going to be equals to its charge. Now, in this case, it is CrO42 minus is going to be equals to minus 2 because of its charge of 2 minus. All right, and then now we want our unknown is Cr, so we place it back the way it is like. So this is Cr, this is our unknown in this case, plus now O4, we need to find out what is then the oxidation number for oxygen. Where is our oxygen? Let's write on top of it. Let's remind ourselves again. So generally the charges are +1, +2, and then +3, right? And then we've got positive or -4, and then over here we've got -3, -2, -1, and 0. All right, so now because we are speaking in terms of oxygen, so it's going to have a -2. Okay, so that means that how many then atoms are there for oxygen? Okay, there is 4 atoms of what? Of oxygen. So it's going to be 4 into, what is then the oxidation number for oxygen? It is -2. And where are we getting that -2? Because of where it is placed in the periodic table. Okay, is equals to -2. And why are we equating it to -2? Because it is a polyatomic ion. Okay, so it has to be equals to each charge. The charge of it right now is 2 minus. Okay, and then now we start working things out so that we find the oxidation number for Cr. Okay, so this is going to be Cr plus into -8, okay, is equals to -2. Okay, and then we transpose. Cr is therefore going to be -2, and then if we transpose this -8, it's going to be positive. It's going to change its sign, +8. Okay, then Cr is there going to be, what is then your -2 plus 8 is going to give us a +6. Therefore, oxidation number for Cr is +6. See how simple that one is. Okay, if you did not find it simple, it's okay. Let's do another one together and find if this one will not be as simple as the first one. Okay, so this one is not a polyatomic ion. Okay, it's just a compound, and we want to find the oxidation number of B, which is your boron, in NaBO3. Okay, so now the first thing you should ask yourself, what is this equated to? Okay, there is no charge in this case, so it's going to be equated to 0 because it is neutral. All right, so it's going to be NaBO3 is equals to 0. All right, we want to find for a B. Okay, where is our Na? What is the oxidation number for sodium? Sodium, there it is on group 1. That means that it will have a positive 1. All right, so this is going to be positive 1. I'm writing all the charges as they are, then plus B that I am trying to find out, and then plus oxygen. But now there are 3 atoms of oxygen, so it's important to say it's going to be 3 of that charge, of that specific oxidation number for oxygen, which in this case, because we're talking about oxygen, is going to be -2. All right, so equals to 0. Okay, so let's solve it out now. So it's going to be positive 1 plus B plus 3 times 2 is going to give us -6. All right, is equals to 0. Let's transpose. Right, B is going to be equals to, when we transpose the 6 to the other side, it's going to be what? A positive 6. All right, and then we move that that positive 1 to the other side, then it's going to be -1. And then this is B. The oxidation number for B is going to be positive 5. Okay, so therefore oxidation number for B, which is your boron, is positive 5. Applying the rules, being friends with the periodic table, understanding what the oxidation numbers of the general charges that are given to the elements is very important. The last one, let's take a look at this one. We are trying to find the manganese in KMnO4. All right, it's a compound. It is not an ion, so it has to be equated to 0. So this is going to be KMnO4 is equals to 0. Then we start assigning the numbers, oxidation numbers, to be specific of what we know. K, potassium. Okay, where is it at? Group 1. So this means that this is a +1 plus this is our unknown manganese. That is what we want to find out. Okay, plus there are 4 atoms of oxygen, so it's going to be 4 multiplied by -2. Okay, because oxygen has got an oxidation number of -2, and then equals to 0. Okay, work it out. +1 plus Mn, and then plus into -8, all right, is equals to 0. This then gives us Mn is equals to, we should transpose to make this a +8 and then a -1. Then manganese will have an oxidation number of a +7. Just as easy as that. So you apply your rules, you become friends with your periodic table, and then it is easier to assign the oxidation numbers of different elements in a compound. All right, so moving right along, now we get into electrolysis. What is electrolysis, you ask yourself? Electrolysis is the decomposition of a substance when electric current passes through it. Okay, so once now there is this decomposition of this particular substance, there will be a formation of what? Of ions. Remember, we spoke about the cation ions, which is your positively charged ions, as well as your N ion, which is your negatively charged ion. Okay, but for electrolysis to happen, it has to happen in what we call an electrolytic cell. What is an electrolytic cell? It is an electrochemical cell, okay, that is responsible for the change in electrical energy to chemical energy. Okay, so it uses electricity to drive a non-spontaneous reaction. And it is non-spontaneous. It cannot just happen on its own because it needs that power supply. We need that electrical energy, okay, for the whole reaction to take place. Okay. Now, electrolytic cell is activated by applying the electrical potential across the anode as well as the cathode. Hence, we say it is non-spontaneous. Okay. Now, remember we spoke about the two electrodes. Again, I want you to take note of them. Nothing has changed. We have an anode, which is an electrode where oxidation takes place, and then a cathode, which is an electrode where the reduction takes place. Okay, for oxidation to take place, there will be a rise or an increase in the oxidation number. Okay. Now, electrolyte. What is that? It's a light now. It's not an electrolytic cell. It's not an electrolysis, but it's an electrolyte. Okay, it is a solution that is able to conduct what electricity through the movement of ions. Now that these salts have dissociated or has decomposed, okay, to form the ions. Now there's this movement of ions. Okay, now that solution that is able then to conduct electricity through this movement of ions, we refer to it as an electrolyte. Okay. Now, the electrodes are made of metal. Could be metal. It could be carbon. Okay. Now, this is important to take note of because we are talking about the same electrodes that we said it is an anode. Also, it is what A as well as the cathode. Now, depending, I always say opposites attract when it comes to this case. Remember, we said there's going to be a decomposition of this substance, okay, through the passing of the current. As the current passes through, there's this substance that is decomposing to form the ions. Cat ions are floating now freely, as well as the N ions are floating freely, okay, in an electrolyte solution. All right. So, what then happens to these ions? Where do they then attach? Okay. Now, the cat ions will be attracted to the negative, or rather to the electrode that is on the negative terminal of the battery, okay? And then the positively charged will be your positively charged being attracted to the electrode on the negative terminal, and then vice versa. Let's look at this thing. Now, when then electricity flows through the electrolyte, okay, the ions undergo a chemical reaction. Hence, there will be cat ions as well as the spectator ions that are there, okay. Then this whole process, okay, of breaking down the substance into the ions, okay, by allowing the current to pass through it is then known to be electrolysis, all right. Now, we can say that this is, and it happens in an electrolytic cell, which is a device or rather an apparatus where electrolysis takes place. Okay, so electrolysis, okay, where we use a metal to plate an object with the metal. We just want to coat it on the outside. All right, so we're going to go through it as we move along, so that we dive into it in detail. Also, we do it to purify the metals. We'll also do it to prepare the chemicals. And lastly, for galvanizing, we want to enhance the appearance of certain objects, okay, by applying a certain metal as a coat on top of it, okay. So this is how it happens. So with your electrolytic cell, the most important component that we have to take note of is that of a power supply. Now, it could be a cell, it could be a battery, but there has to be a power supply. All right, and then we've got two electrodes that are there. We've got your anode, okay, and then we've got your cathode. Now, remember, an ox-red cat, an ox-red cat, an ox, say it with me, red cat. This means that anode, here's my anode, what happens there? Oxidation, okay. red cat reduction takes place where? On the cathode. Okay. Now, how do you then identify? Okay, if you're not told, for example, if these two were not written in here, how would you know which one is which? How would you know this one is an anode? How would you know this one is a cathode? Okay, so on the positive terminal, so remember, let me just write this like this. If this cell was written like this, okay, let me just write one to avoid, well, for you not to be confused for now. So this is the positive terminal of the battery, and this is the negative terminal of the battery. Okay, now the anode is on the positive terminal. Is this the electrode that is attached to the positive terminal of the battery, whereas the cathode is the one that is attached to the negative terminal of the battery. Okay, so that's how, because it will not always be like, well, the way I've drawn myself will not always be like that. In some other question papers, you can find it like that. It is important to note that this is still a negative terminal of the battery. This is still a positive terminal of the battery. In this case, it is important to note that this is my anode. Okay, the electrode that is attached to this positive terminal is my anode, and on the side, the electrode attached on this side will be my cathode. We're going further to say, what is it that happens on the anode? It's oxidation happens. What is oxidation? It is the loss of electrons. How exactly will I identify that a loss of electron has happened in here? You will see an increase in the oxidation number. Cathode. What is a cathode? It is an electrode where reduction takes place. All right. What is reduction? It is the gain of electrons. How will I identify in a chemical equation that reduction did take place there? There will be a decrease in the oxidation number. All right. Now, this is specifically for the decomposition of copper chloride solution. All right. So we had copper initially. It is blue in color. All is well. All right. And then it decomposes, meaning the electrolysis process then begins to take place. What happens? This, when we decompose something, it becomes split. It forms the ions. Okay, there's a movement of ions now. There's cation, there's anion. They're floating freely in this electrolyte. All right. Now, we've got your Cu2 plus floating nicely. And then we've got your Cl minus floating very nicely in this liquid. Okay, we call it an electrolyte because now it has the movement of ion, therefore it is able to conduct electricity. Right. Opposites attract. Remember what we said? All right. Now, because now there is a positive terminal of the battery connected to this electrode, it's going to attract the N ions. Opposites attract. The positive terminal or the positive electrode will attract the N ions. Okay, on this side now we're gonna have what your Cl minus. Here's my Cl minus being attached on this one, and because chlorine exists in the form of a gas, okay, how we know yes chlorine has attached on this electrode, it's because you're going to see the greenish bubbles, okay, being attached all over it. So all these greenish bubbles are chlorine. Okay, and then on this side there's going to be a reddish brown coating. Okay, so that is going to be our Cu2 plus, which are attached in here. And because they are cations, that is why they are attracted onto the electrode that is connected to the negative terminal of the battery. Okay, here's my copper, and how we see that copper really has attached into or is attracted into this electrode is because of that reddish brown coating. Okay, so now the N ions, it just chooses the opposite and just moves on either side. Okay, that's how we know electrolysis really did take place. The current really did pass through this substance, caused it to break down or to decompose, okay, into simple ions, okay, cations as well as your anions. Okay, let it is as simple as that. So if then the question comes through to say, write down the half reaction, okay, that has happened in the positive electrode or the negative electrode, then you are able to just write a correct the half reaction. Okay, so what is it that we'll observe when this specific electrolysis, the decomposition of copper 2 chloride solution, takes place? Initially, it is important to note that it had a blue color, okay, in a solution, and it remains unchanged like that. And then it appears that copper has been deposited on one of the electrodes but dissolved in the other. What is it that we need to take note of? Now, at the negative electrode, we call it a negative electrode because this is an electrode that is attached to the negative terminal of the battery. Okay, the positively charged copper ions are attracted to the negatively charged electrode. These ions then gain electrons, okay, and because that is where reduction takes place. Okay, how then we will then put this in a chemical equation? Now, copper was looking for electrons, okay, copper was looking for electrons. It was a cation looking for electron. It then gained these electrons, okay, become whole. So looking at the oxidation numbers, what is it that had happened? We had an oxidation number of what? Of positive 2 over here. We had an oxidation of positive 2. I want to write using red. So we had positive 2 because we said in a monoatomic ion, okay, the oxidation number is equals to its charge. Okay, change from positive 2 to what? To 0. Remember, we said how we will know that oxidation has taken place. There will be an increase in the oxidation number. Okay, how will we know that reduction has taken place? There will be a decrease in the oxidation number. Let's look at this one. So we had a positive 2. I love the Cartesian plane. Simplifies life. The numbers going up, okay, are positive 1, 2. So from a positive 2 to a 0, there was a decrease. What does it say? There was what? Reduction. Okay, there's a gain of electrons. Okay, moving right along, let's look at what happens onto the positive anode electrode. At the positive anode, there's a greenish bubbles that are observed. We did see the greenish bubbles. Okay, what happens? The chlorine ions are oxidized and they form chlorine gas. All right, then half reaction that takes place is as follows. So we've got a Cl2, okay, and then giving 2 Cl minus, okay, it has to indicate the loss of electrons. Okay, so over here, because it is a, well, not really an ion, but it has just the same, the element, there's just same elements, 2 atoms of the same element. So it's going to have an oxidation number of 0, okay? And over here, chlorine then has a charge because now it is an N ion. So the oxidation number now is what? It is -1. Okay, so what has happened in here? So it has done what? It has lost the electrons. So there's oxidation that has happened. All right. Now, what is electroplating? Why do we then do electrolysis for the benefits of doing electroplating, which is mostly what we are mostly focused on? Electroplating is the process of using the electrode deposition to coat an object in a layer of metals. Okay, depending on the metal that you want to use or you want to coat it with. If you want to coat it with gold or silver, it is okay. Now, engineers use controlled electrolysis to transfer the desired metal coating from the anode to the cathode. So that means that the metal that you want to coat with has to be on the what? On the anode, and then the object you want to coat has to be on the cathode. Okay? Why are we even doing this? We want to improve appearance. It could be that our object is dull and you just want to make it glitter, more appealing to the customers, okay, and to improve functionality of many appliances and components around the kitchen. For example, your utensils, your cutlery, your pans, your taps, your kettles, and all of those. All benefits from electroplating is as that we want to enhance its appearance, its functionality, okay, and that is why we are more interested in electroplating. So this is how your typical electroplating process would look like. We have, in this case, our silver on the side. That means that silver is the metal that we want to plate our spoon with, because we had to put a spoon in there. Okay, so we want now silver to be deposited around this spoon. So what will happen is that silver will come and be deposited. This spoon will appear more shiny and more silver because of the movement of the metal from the anode into the cathode. Remember, all the time, the cases where this could just go wrong is when now you are taking the object and putting it onto an anode and taking the metal and putting it into the cathode. Then we would have failed as a generation, because now there will be no plating that happens. So the metal strictly has to be on the anode, and then the object we want to plate has to be on the cathode, because this is where the gain is at. All right. Now, we cannot just complete our lesson by not going through the multiple choice question, which is very important. Okay, remember, in the papers that we're going to write and the test that we're going to write, there's always going to be the multiple choice question. The skill is the most important thing. 4 possible answers are given. All right, and then 2 of them are your distractors. They are there to distract you. There's nothing that is good that can come out from you choosing those options as your possible answers. All right, and then we've got the one that is similar to your answer but is not correct, and then we've got your correct answer. All right, so it's important. This means that we need to get to know, we need to study with a certain strategy. Okay, we need to get our facts correct so that we are able to just pick up quickly which ones are our distractors, which ones are our, which one is similar but is not really correct, and which one is the most correct answer. Okay, because only one is correct from all the 4 options that is provided to us. Okay, so I usually say 2 max 2 minutes. Once you spend more than 2 minutes in that, and all you can get is 2 max, something is wrong. Okay, so on this specific one, consider, it reads as follows: consider the chemical equation for the reaction between lead and copper below. Which one of the following statement is correct? Even before you can even dive into your options, put on your oxidation numbers. Identify which one is an oxidizing agent, which one is a reducing agent. Then when you get to just look at your options, now you are aware of what you are looking for, so that you are avoiding where you're just picking your favorite alphabet for the like of it. Let's look at lead. Okay, lead here has an oxidation number of 0. But when you look at lead now, it is an ion, cation to be specific. So it has a 2+ oxidation number. What happened here? There's an increase in the oxidation. So there's a loss. So there's an increase in the oxidation number. So from a 0 to a +2, 2+. So this means what happened? over here are two things I want to identify. So it's oxidation happened here because oxidation took place here. So that means that lead is a reducing agent. Okay, done. Let's look at copper now. Copper had a 2 plus oxidation number, and it went from 2 plus to a 0. From a 2 plus to a 0. So there was a decrease, okay, of the oxidation number. What does a decrease in oxidation number tells us? The reduction happened, okay? So I'm identifying two things here. Reduction happened, and if reduction happened, that means copper is then our oxidizing agent. Right. Then now when we're diving into the options, the possible options that we have as correct answers, it says which one of the following statement is correct? Copper is oxidized. Then you look at what you've done. Is copper oxidized? No. And it acts as a reducing agent. Definitely it is a no. Lead is oxidized, okay, and acts as a reducing agent. Yes. Lead is oxidized and is a reducing agent. This is correct. Copper ions are oxidized. Okay, no, because copper is reduced. It's a definite no. Lead ions is reduced. Okay, a definite no. Lead ions are not reduced, they are oxidized. Okay, so it's a definite no. So the correct answer over here, it is B. So you see how simple it is when we now know the how to assign the oxidation numbers, then everything becomes easier. Let's attempt another one. It's a multiple choice question number 1.2. What happens to N ions during electrolysis? What is it that we have to know about N ions? Let's remind ourselves real quickly. N ions are negatively charged ions. Okay, so these are the ones that are negative. And in an electrolysis, we had said that opposites attract. So the negative ions will be attracted to an electrode connected to the positive terminal. I'll say that again. Negative N ions are attracted to the what? To the positive electrode. Okay, so will they move towards the negative electrode and are oxidized? They can't, because now will be negative to negative. They move towards the negative electrode? They can't. So A, B, definitely wrong. It can never be that. All right. And then they move towards the positive electrode and are oxidized. Or they move towards the positive electrode and are reduced. Then this speaks to, do you know what happened? Do you know the reaction, or rather, what is it that happens on the positive electrode? Is it oxidation or is it reduction? It has to be oxidation. Our correct answer is C. See, as we then get into the content of what is an anode, what happens in an anode, then getting our correct answer becomes more simpler. All right, so that is what we meant when we said we've got distractors, A and B being our distractors, and then D being an option that is similar to, okay, but not correct, and C being our correct answer. 1.3. Which one of the following statements is true for the reaction? Okay, so we've got magnesium reacting with oxygen and forming magnesium oxide. Let's assign again before you even look at your possible answers. Let's assign the oxidation numbers. Okay, so over here magnesium was 0. Okay, and then over here magnesium is +2. So what has happened? There was an increase. Love my Cartesian plane. There's an increase in what? In the oxidation number. So if there's an increase in the oxidation number, it means that there is oxidation that took place here. Oxidation that took place, and then magnesium will be a reducing agent. Oxygen, what happened here? What is it that happened here? It was a 0, okay, and then it became, remember oxidation number for oxygen, it is a -2. So there was a drop from a 0, there was a drop. What has happened in here? Reduction. So this means it's an oxidizing agent. Done. Look at your options, the ones that you have. Magnesium is the oxidizing agent and gets reduced. Magnesium is an oxidizing agent. Remember, our oxidizing agent is oxygen. So it is wrong. Magnesium gains electrons. Magnesium gains. What is the gain of electron? It is reduction. And when we do the oxidation number, it shows that magnesium underwent what? The loss of electron. It's a definite no-no. And then oxygen, O2, is the oxidizing, okay, agent and gets reduced. Okay. It's correct. Let's look at oxygen is a reducing agent, okay, and loses electrons. It's a no-no. All right. So we're looking for the O2, which is your oxygen. It is an oxidizing agent. There it is, and it's get reduced because it undergoes reduction. Okay. So our correct answer is C. And then looking at the last one, during the electrolysis, the breaking down of a substance, decomposition, okay, of a substance. During electrolysis, the substance at the cathode loses electrons, all right. Anode increases in mass. Cathode decreases in mass. Anode loses electrons. Let's do it again. Cathode loses electrons. No. NOx, red cat. NOx, red cat. Cathode, a reduction. That means there has to be a gain of electrons. So it's a no-no. In anode, increases in mass. How can anode increase in mass when we are taking from the anode? So it has to be a decrease in mass. So it's a definite no-no. Cathode, decrease in mass. It's a no-no because cathode will increase in mass. All right. And then D, anode loses electrons. Very correct. Anode loses electrons because in the anode, that's where oxidation happens and it is the loss of electrons. Okay, so this is how then we get a skill by attempting the multiple choice questions all the time, every day. Just give yourself, on that specific chapter, give yourself the multiple choice questions so that you learn to the skill of answering properly. Moving right along on the long questions, redox reactions. Now we know what redox reactions means. Okay, reduction, oxidation reactions that happen simultaneously. Right. Play a vital role in a wide range of everyday chemical processes, from the rusting of ions to the operation of batteries and certain biological processes in the human body. Right. And then the 2.1 goes on to say, differentiate between oxidation and reduction, because that is the foundation of the whole thing. Differentiating, how is oxidation different from reduction? Oxidation is the loss of electrons, whereas reduction is the gain of electrons. It's more like you're providing the definitions for the two processes. Okay. Continuing with question 2, 2.2 goes on to say, determine the oxidation number of the underlying substance in each of the following. Okay, magnesium in magnesium chloride. Okay, so we want to find now the oxidation number for magnesium in magnesium chloride. So that means that because it is a compound, we have to equate it to 0. So we say Mg Cl2 is equals to 0. Now, our unknown, the one that we're trying to find out, is Mg. Okay, so it's going to be Mg plus into, there are 2 atoms of chlorine. So plus 2, okay. Where is then, you didn't look at your periodic table, where is your chlorine? There is our chlorine. Let me assign the general deduced charges of the ions here. So it's positive 1 to remind you a little bit, positive 2, and then we've got a positive 3, positive or negative 4, and then we've got negative 3, negative 2, negative 1, and then 0. Now, because we are looking for chlorine, that means that there is our chlorine over here. So it's got a charge of, or rather an oxidation number of negative 1. So this is times negative 1 is equals to 0. So if we then do our just calculation, is going to be 2 times negative 1 is going to give us negative 2, which is equals to 0. Then our Mg is equals to, if we transpose, it's going to be a positive 2. That means our oxidation number for magnesium is positive 2. All right. Next one. Now we've got, let me just erase a little bit so that it is visible from here. Okay. I'm just going to continue on this side so that it doesn't hinder us from seeing the next question. Okay, we're answering for, I'm just going to complete it here. We said Mg is therefore equals to a positive 2. Right. Okay, created a smaller space. And then we are then now looking at well, it's a polyatomic ion, all right? So we've got NO3 minus, and we are looking for the oxidation number for nitrogen, okay? So what do? We equate it to, because it's a monoatomic ion, so it has to be, the oxidation number is equals to its charge. So this has to be NO3 minus is equals to minus 1. Okay, and we're looking for nitrogen, so it's our unknown, plus into 3, there is 3 of oxygen. Oxygen, there is what? Minus 2, having an oxidation number of minus 2. So it's going to be 3 times negative 2 is equals to minus 1. So this is then N plus 3 times 2 is going to be giving us negative 6, which is equals to negative 1. We transpose, and then nitrogen is going to be equals to negative 1, and then when we transpose, it's going to be a positive 6. Okay, nitrogen then is going to be equals to negative 1 plus a 6 is going to be a positive 5. Nice, no? Right. And then moving right along, Na2CO3. We're looking for oxidation number for carbon. All right, it's a compound. We are equating it to 0. So Na2CO3. All right, I got everything right. Equals to 0. Okay, because it does not have a charge. So that means that we are looking for carbon. Here is my sodium on group number 1. So it's going to be 2 of what? Of plus 1, okay, plus the carbon, okay, which is our unknown in this case, and then plus there is 3 atoms of oxygen. Oxygen is a minus 2, all right, is equals to 0. Okay, now 2 times a 1 is going to give me a 2 plus a positive 2 for that matter, carbon plus into -6 is equals to 0. We transpose graciously. So we then going to have a +6, all right, and then a -2. Okay, because if we move this -6 onto the other side, it's going to be positive, and then if we move that positive, it's going to be -6 minus 2, then gives us a 4. Positive 4. Therefore, oxidation number for carbon in Na2CO3 is going to be +4, or rather is +4. Okay, so this is just learning how to assign the oxidation number. Now let's move along to determining the oxidation number in a balanced chemical reaction. All right, what does this one say? F2O3, okay, plus 2Al. So it's iron oxide reacting with aluminium. Okay, all right. Even before we can even look at the questions, remember what we said? Let's just assign the oxidation numbers, okay, of each element in this compound. Okay, on here, let's start with iron, all right, shall we? And then we've got iron. I'm just gonna move nicely to here. Right. Ooh, okay. Right. So iron over here is a 3 plus. It is reacting with oxygen. And then over here there is 2Fe. So there is 2 atoms of the same element. Okay. So remember the rule. It will be 0. Okay. And then we look at aluminium. Aluminium over here, let me just draw where aluminium is at. So we've got a 0 because we've got 2 atoms of the same element. And then aluminium in here, it is a 3 plus. Right. Let's look at what happened here. For iron, there was a decrease in oxidation. Cartesian plane once more. From +3 to a 0, there was a decrease. If there's a decrease in the oxidation number, is reduction. So over here, iron underwent reduction, and that means that it is a oxidizing agent. And then over here, there was an increase from 0 to a +3. That is aluminium. Okay, there's an increase in the oxidation number, so it underwent oxidation. Therefore, it is a reducing agent. Then we look at the questions. Right. Okay. 2.3.1. Explain why this is a redox reaction. Because there's a transfer of electrons. Remember, in redox reactions, there's a transfer of electrons. Okay? Because there is a transfer of electrons. That is why it is regarded as a redox reaction. Okay? 2.3.2. Which substance is undergoing reduction? Which substance is undergoing reduction? And when you have done your analysis at the top, it is easy because there's your reduction. What were you specifying on? It's iron. Okay, so iron is the one that is undergoing reduction. Okay, Fe, that is. Moving right along, we're still considering the same chemical equation, okay? However, we are now focusing on which substance is the reduced agent, okay? Again, because it has happened on the other slide, we said that we have iron over here. It has a 3 plus, it has a 0, okay? So now, and then we looked at aluminium with a 0, and then we have a 3 plus, and then we concluded to say because over here there is a decrease, it is undergoing what? Reduction, because there's a decrease in the oxidation number. This is an oxidizing agent, whereas the aluminium, there was from 0 to 3 plus. This is an increase in the oxidation number, so it's undergoing oxidation. Okay, and when it's undergoing oxidation, that substance that undergoes oxidation then is a reducing agent. Now, when a question like this comes, which substance is a reducing agent, then it becomes simpler for you to say it's just aluminium, because you've just analyzed everything in order. Okay, so aluminium, you can say Al, or aluminium, writing it in full. Give the reason for the answer. Why are we saying it is aluminium? Why is aluminium a reducing agent? Because it is a substance that undergoes oxidation. Okay, as simple as that. So that's how then we come to an end of our question 2 regarding the oxidation numbers, whether be it you just assigning, or you're trying to find a oxidation number of a specific element in a compound, or you are given a balanced chemical equation and you have to find it from there. Okay, because we need to learn the skill from both ends. And then question 3 goes on to say the diagram below represents an experimental setup for electrolysis, a CuCl2 solution. Okay, carbon electrodes are used in this electrochemical cell. Okay, now it's important to read. Please take note, read the statement that is given to you all the time. Okay, because it gives you a clue what is it that is happening in that specific question. Also, analyze the diagram. Okay, be very clear about what is it that you are dealing with. Okay, in this case, component D, okay, because we know this is just a what? An electrolysis. We know that we had mentioned that electrolysis happens or takes place in an electrolytic cell. So we are very much aware that this is an electrolytic cell. All right. In knowing that, we understand that electrolytic cell is a non-spontaneous cell. Being a non-spontaneous means that it won't happen on its own. It will need a power supply for the decomposition of the copper chloride solution in this case. All right. So that means that our component Z is our power supply. Could be a battery, could be a cell. All right, but it will have a positive and a negative terminal, and then they indicate the positive and the negative. Okay, this is just from the battery side. That means that this is the positive electrode and this is the negative electrode. All right, so we're going to take the diagram along with us so that it is clearer how then to answer the questions that follow. All right, so here's our diagram right at the top. What is meant by the term electrolysis? Okay, electrolysis is the decomposition of a substance when the electric current passes through it. The decomposition won't happen on its own. It will need the electric current to pass through it. All right. And then the second question, it says, write the name of the electrolyte. And please pay attention to this one. The name. It's not the formula, but they are looking for the name. So the name of this one will be the electrolyte. In this case, the electrolyte is our copper 2 chloride. Okay, And then we are then moving right along. What does the component Z, here's our component Z right there, represent? It represents the power supply. And another person could say it represents the battery. Okay, moving right along, we have also a 3.4. It says define the term oxidizing agent. What is an oxidizing agent? It is a substance that undergoes reduction. See, when you get your fact in order, everything is simple. When you get to an exam, you are attacking the question paper. You are attacking the question paper. Okay. 3.5 goes on to say, write down the name or formula. Ooh, and then this is then now where you are flexible like that. You can either write the name or the formula. But on cases where the question is very specific to want the name, please pay attention to that. When they want the name, write the name. When they're looking for the formula, write the formula. But if they give you flexibility like that, then you have the luxury to choose either or. Now, 3.5 goes on to say, write down the name or formula of the oxidizing agent. And the oxidizing agent is that the one that undergoes what? Reduction. And which one is going to undergo reduction in here? The one that's going to attach onto the what? The negative terminal or the negative electrode. What is it that's going to be attached there? Because we said opposites attract, it has to be copper. Copper. 2+ in there. Okay? So we get on to say it's going to be copper. 2+ is the one that's going to undergo reduction, is the one that's going to gain, okay, electrons. Okay? 3.6, which one of the electrodes, that is X or Y, is an anode? Ooh, which one? X or Y is your anode. Remember, your positive electrode is your anode. Okay, so we've got the X this side and we've got Y that side. So it's very simple. It is Y. Okay, maybe let me write in full and say electrode Y. Electrode Y. Why? Because the positive electrode is the anode. Okay. Moving right along on question 3. We're still on question 3, that is. Which ions, okay, is it the cation ions or the anions that will move forward, that will move towards the cathode? That means that we need to be able to know which one is our cathode. Cathode is the negative one, the negative electrode. Okay, so because now we know this is our cathode, all right, we said opposites attract. So the cation, the ones that are positively charged ions, will move towards the what? The cathode. Okay, so it has to be the cation. So we see, we just keep repeating, but in different, they're phrasing the same thing differently. Okay, they're phrasing the same thing differently. Yes. And then 3.8, what observations will be made at electrode Y? What is it that we'll see in its electrode Y? Electrode Y is a positively charged electrode, right? And then meaning that it is connected to the positive terminal of the battery. Okay, so that means that it will attract the N ions. N ions in this case will be that of chlorine. And so if they say what observation will be made, we'll have like greenish gas bubbles. Okay, because chlorine exists in the form of a gas. So that is our electrode. So greenish chlorine bubbles. (3.9) Write down the half reaction that takes place at electrode X. Electrode X. Here's my X here. Remember we said Cu2 plus attaches here, because this is our cathode. It's where reduction takes place. What will happen? Okay, Cu2 plus gaining electrons and becoming Cu. Okay, what is it that will happen at electrode Y? Electrode Y, there will be a formation of gas bubbles. Okay, all right, so there will be a loss because it's an anode. Okay, so it has to be Cl2. Okay, 2Cl minus plus 2 electrons. Let's show the loss of electrons. Okay, so now having attempted, or rather did, the multiple choice questions together, the long questions together, conquered the content for oxidation numbers, conquered the content for electrolysis, now I want you to be a hero and conquer this task. And I know you can do it. Okay, this is a question 4, which I want you to now to attempt it on your own, to check yourself if you did enjoy today's content. Did you understand everything? Okay, since I did not get any questions, I assume everybody is sorted, right? So this is a question 4. It reads on to go, chemical change deals with a variety of chemical reactions, including electrochemistry, which is a branch that deals with energy conversion because of chemical reactions. 4.1, distinguish between oxidation and reduction. That is a very simple 4 marks. Okay, then 4.2 goes on to say, identify cation in the following compounds: CuCl2 and Na2S. Okay, 4.3 then says, define the term oxidation number. What is an oxidation number? Okay, 4.4 goes on to say, calculate the oxidation numbers of the underlined elements in the following compounds. And then they show us the underlined, and then those are our unknowns, the one that we're trying to find the oxidation numbers for. Okay, and then 4.5, study the balanced chemical reaction below and identify the reducing agent and the oxidizing agent. So for us to conquer that, please assign the oxidation numbers in that chemical equation. Okay, element by element. All right, and then today I want to end today's lesson by Abraham Lincoln. He said that the best way to predict your future is to create it. Let's not predict only, but let's create it. And we start now in creating how our future will go and look like. Okay, hope you enjoyed today's lesson. I really do hope you did. Okay, see you next time. It's a goodbye from me. Thank you.